Welcome back to our sign part video series. In the last video, we covered the basics of an engine lathe, including how to load a workpiece, how to load a cutting tool, and how to safely turn the machine on and off. In this video, we're going to cover all the manufacturing steps to produce this wheel hub. As we begin, the first thing we need to cover is basic spindle speeds that we should use depending on what operation we are performing. So let's take a look at that chart. The spindle speed chart shown on the screen was created specifically for use on the lathes in our laboratory. Regardless of whether you are turning the outside diameter of a workpiece or whether you are drilling holes in the center of a workpiece, the speed chart applies. To use the chart, you first identify the type of material being cut, whether it is a softer type of material like aluminum or a stronger and harder type of material like steel, and the type of operation being performed, whether you are turning the outside diameter of a part or whether you are drilling a hole through the center of a part. Once the material and process are identified, we know which line to reference on the spindle speed plot. For example, if we wish to drill a 1-inch hole through the center of an aluminum workpiece, we can identify the correct curve and see that the suggested spindle speed would be approximately 200 RPM. This particular chart is limited to 600 RPM because of the dangerously large amount of rotating inertia or kinetic energy associated with a lathe chuck spinning faster than this speed. The first step is to turn the machine on so we can then touch off on the rotating workpiece to set a zero and proceed with the rest of our machining. Before we turn it on, we want to always follow that three-step check we introduced previously. The first step is to put the machine in neutral and carefully rotate the workpiece through one revolution to make sure that there's adequate clearance between the rotating part and the cutting tool. Next, I'm going to return the machine to high range because that's what we'll use for most of our cutting in this video. And then finally, I want to make sure that I turn the machine on, I turn the spindle on in the correct direction via the power switch. So we'll be able to tell by watching. We want to see the chuck rotate in the counterclockwise direction as viewed from the tailstock looking towards the headstock. So I'll turn it on. That's the correct direction. And now we're ready to touch off on the rotating workpiece. As I move the Z-axis hand wheel, it works just like the steering wheel on your car. If I move to the right, it moves the cutting tool to the right. If I move to the left, the results are exactly as expected. The X-axis hand wheel, to use it properly, we want to employ the right-hand rule. If I use the right-hand rule, this tells me that rotating the X-axis hand wheel in a clockwise direction is going to advance the tool towards the workpiece. So let's check that. As I rotate it clockwise, indeed, we can see the tool move towards the workpiece center line. If I rotate it counterclockwise, then it's going to move the tool back towards me, towards the operator, away from the workpiece. Okay, so you always want to use the right-hand rule to make sure that you're moving the right direction, and also start your move slowly and only pick up speed once you're sure you're moving the correct direction. I'm going to move in towards the workpiece. Now the cutting edge is basically on top of the workpiece, and I'm going to slowly move it into contact with the rotating workpiece in the Z direction. So I'm going to use the Z-axis hand wheel, and I'll move over close to my workpiece, and then I will slowly bring it into contact until I hear it cutting and see a chip being produced. So there's the chip. I can hear it because I'm close to it and I'm operating it. So I'm going to stop my Z-axis motion, and then I'm going to reach up and I'm going to set that as my Z-axis 0 or my Z-axis datum. So for the Z-axis on the DRO, if I press the yellow arrow, it is going to 0 the readout. So now that will match the datum on our part drawing. I want to move the tool off the workpiece. So again, right-hand rule is going to tell me to move this the X-axis hand wheel counterclockwise. I'm going to do it slowly to make sure I'm moving the right direction, and then I can pick up speed. Okay, I have 2 zeros to set because the lathe has 2 axes of motion. So now I need to move over to, so that the cutting tool will contact the outside of the workpiece. So I'll move in the Z direction. I'll move towards the rotating chuck. And now I'll slowly move the tool into contact with the outside of the part so that I can set my 0 in the X direction. So I come in close. I can use my eyes to know when to slow down, and then very controllably, very slowly, very carefully come into gentle contact with the rotating workpiece. I can just see the chips being produced. I can see a very shiny surface being produced as well. So both of those are indicators that I just touched the surface of our rotating part, and now I'm ready to set the 0 in the X direction on the DRO. So I'm going to 0 the X value this time. And now we have our 2 reference datums to proceed forward with. To face off the front of the part, we need to slowly move away from the workpiece in the X direction. And in the Z direction, I will move the cutting tool back to the 0 that we set. And now I need to move in towards the workpiece the amount of material that I wish to remove during this first cut. I'm going to cut about 20 thousandths of material off the part. So I move 20 thousandths towards the chuck. And now as I move the cutting tool in towards the workpiece, I can gently come into contact with the part. And if I move all the way to the center line, I'll perform a facing cut that ensures the end of the part is normal to the axis of the rotating workpiece. You can see I'm using both hands to try and make the motion as smooth as possible. I can use one hand as well. I think it's a little more jerky if I do that, but however I want to use the hand wheel to try and control the motion as smoothly as possible. I'm going to cut all the way to the center. And once I'm there, I'm going to move away from the workpiece in the Z direction. And I'm going to move back out, away from the part in the X direction. And we now have a smooth, machined, finished surface on the face of our part. Next, we're going to make a cut across the outside diameter of our workpiece, since the note specified that we must finish all surfaces. To do this, however, I'm going to use the automatic feed this time to show the difference between feeding the tool manually, like we did when I just faced the part, versus the cut we'll make this time. The automatic feed, it's going to give some advantages. It's going to give us a little better surface finish, a little more consistent, and over time it reduces operator fatigue as well. To demonstrate the automatic feed, I'm going to move to the right, out here in space, where I'm safely away from the material. The controls for the automatic feed are on the front of the carriage, what's called the apron of the lathe. The main feed selector handle, it lets us switch between longitudinal or Z-axis motion and cross feed or X-axis motion. And there's a nice little hieroglyph on the front of the carriage that shows us which direction is appropriate for what we're trying to do. In this case, I'm going to select longitudinal feed because I want to move the cutting tool in the Z direction to take a light cut across the outside diameter of the workpiece. When I move the handle, in this case I move it vertically, as I actuate it, you can see the Z-axis hand wheel begins moving automatically. Okay. The plunger at the bottom, it's used to change the direction of motion when you're using the automatic feed. So I pull it out for one direction and I can push it in for the other direction. In this case, we want to move from the tailstock towards the headstock, so this is the appropriate direction of the hand wheel. I'm going to turn the automatic feed off, and now I can move in close to the workpiece and we can begin the cut across the outside diameter. I'm going to move over in Z. I'm going to come into my X0 that we found when we touched off on the outside of the workpiece. I'll slowly come into the 0. And in this case, let's take a very light cut for the first cut across the outside of the part. So we'll try 5/1000ths of an inch. Okay? So X is at 5/1000ths of an inch into the workpiece. I was using the right-hand rule again. I have the automatic feed set on the Z-axis, and the direction is set moving towards the workpiece or towards the chuck. So now, if I activate the automatic feed, it's going to move the appropriate direction, the correct direction. It's a good practice to manually move the tool in and touch off first, just to make sure that everything is working properly. In this case, as I do it, You can see the contact between the cutting tool and the workpiece. So now I'm ready to actuate the automatic feed. The cutting motion commences. And as I begin cutting, I can look at the digital readout. We know our part is 1.5 inches in length, so I'm going to go a little bit past that, which in this case, maybe 1/8 of an inch longer. So somewhere between 1 5/8 and 1 3/4 of an inch. However, I'm going to stop the lathe early and turn it off because I can see already, now that the machine is safely off and I can put it in neutral, I can see already that only a small portion of the outside diameter of the workpiece is actually being cut. So we can see the dull silver color, and then we see the shiny silver color showing the machined section of the part. Okay, this is pretty normal because when we buy material, it's never perfectly round or perfectly flat. It's just close to it as it's made during the extrusion process. So the lathe and later on the milling machine will see that they're able to actually produce much more geometrically accurate shapes. And all this is telling us is that we need to cut a little more material off in order to clean up the outside surface of the workpiece. This right-hand rule tells me how to back away from the part. I'm going to move towards the front of the part. I'm going to repeat that process one more time, taking a little deeper cut this time. So I'll turn the machine on. Oh, sorry. I'll put it back in. I'll check my clearance. I'll put it back in high range. I'll turn it on in the forward direction. Now I'm going to come back into my 0 in the X. Last time we tried to take a 5/1000th of an inch cut. This time we will move into 10/1000ths of an inch, and we will repeat that process. Come up close to the part, slowly make contact, activate the automatic feed. And I can see already that that is not enough either. So I'm going to back out one more time. Feed in to 15/1000ths. So just 5/1000ths increments each time. And repeat it. I'll speed up the lathe to finish the pass. We're going to stop. When we get to about 1 5/8 or 1 3/4, I'll stop the automatic feed. I can finish it up by hand if it matters. Move out away from the part. Back to where we started. If I turn it off, we can see that the majority of the part has been nicely machined, but there's still a small section that is low or has not yet been cut. So we have to keep going until we clean up the entire outside surface, since that's what the notes on our drawing specify must occur. So I'm going to turn it back on. Feed back in. This time to 20/1000ths. Come over close to my part and resume the cut. Okay, this time we can tell from the tailstock camera that the whole surface is cleaning up as we desired. I'll feed in again until approximately 1 3/4 of an inch. Okay, looking at the DRO. I will stop when I get close, and I'll finish up the last little bit by hand. Now I'm going to move away from the part in the X, so counterclockwise on my X-axis hand wheel. Move away from the rotating chuck using the Z-axis hand wheel. Safely turn the machine off. Okay. And now we're able to measure what we've done. Next, let's use our calipers to verify the amount of material that the DRO told us we removed from the workpiece. For starters, we'll measure the outside diameter of the raw stock, which in this case is about 2 inches, 2.000. Next, we'll measure the size of the machined cylinder that we produced, which is about 1.980 or 1.981, right in the area that we would expect based on the 20/1000ths material that the DRO told us we removed off the outside diameter of the workpiece.